Hi everybody, welcome to another video in Algebra, section 8.2, arithmetic sequence. Let's look at first example. Consider the following sequence 5, 7, 9, 11 and so on. Write the recursive formula for it. Well, we know the first term is going to be 1. It'll be 5 when n equal to 1. And how do we go from this term to the next? We're going to plus 2, right? In this case, go from this to the next, and that gives us the next term. So we say this term is equal to the previous term plus 2 4, and if we put 2 in here, we have a sub 2 equal to 2 minus 1, so a1 plus 2, so n greater than equal to 2. Or we can say n greater than 1, but n greater than equal to 2. That's why we write here. So arithmetic sequence is a sequence in which each term after the first differs from preceding term by a constant, and that constant is called common difference. Now write the first 4 terms for the arithmetic sequence for that. So easy, we know the first term is 6. Now the second term a2, meaning we're going to put 2 here and here, and that gives us a1 minus 2. a1 is 6 minus 2 is 4. Now a3, put 3 in for n, so have a2 minus 2. a2 is 4 minus 2 is 2. a4, 4 minus 1 minus 2 give us a3 minus 2. a3 is 2 minus 2 is 0. Now we can also write like this. 6 start with a1, and then we subtract 2 to get to the next, subtract 2 to get to the next, and subtract 2 to get to the next. That just keep going on indefinitely. Now write the following sequence. For the following sequence, determine the common difference and find the 100th term. Right? Now, so this is because when we see the common difference, so this is a arithmetic sequence. So how do we go from this term to the next? Well, what we say is going to be plus 3 right. So now think about this. Let's write out a1 a2 is 1. So let's write like this. a1 is negative 2, a2 is negative 2 plus 3, a3 is negative 2, and then 1 plus 3, 2 plus 3. a4 is 1, 2, 3. So we see if we want to go to the 4th term, we're going to take 3 steps. If we go to the 3rd term, we take 2 steps. So if we keep going like this, the 8th, the 100th term, how many steps do we need to get there? Well, again, the 4th term we need 3, the 3rd term we need 2. So it is 1 less step from the first one. So a100 start from negative 2, and we're going to take 1 less than 100, which is 99, and each step is a plus 3. So that's why we have 99 times 3 to 97 minus 2 to 95. So now that's nice, you know, but we should have the formula for that. Remember, to get to a particular term of arithmetic sequence, we want to start from the first term, and we want to take one less steps to go from first to that term. So if we have for arithmetic sequence, if we have the first term, the common difference, so the general term is equal to a sub n, to start from the first and take n minus one step, and each step is a common difference. So like in this case plus 3 for that example, but we just start from the first one, take n minus one step, and each step is a common difference. Right, so we have arithmetic sequence a sub n is starting from the first term, take n minus one step, and each step is a common difference. So write the a term if a sub 1 is 4 and d is equal to negative 3. Well, so that's obvious, right? We start from there. Just write that again. In this case, the a term, meaning n equal to 8. So we put 8 in for n. And we do know the first term and the common difference. So a1 is going to be 4, a minus 1 is 7, d is negative 3. So 4 minus 21 minus 17. Right, minus 21 plus 4 minus 17. Right. Next, write the general term for this and use it to find a sub 20. So we're going to need a sub n equal to a1 plus n minus 1 times d. So if we know the first term and we know the common difference, we can write the general term. So the general term for that. So the first term is 3, obviously. And to get from the first to the second, in this sequence, we're going to add 4. 3 plus 4 is 7, 7 plus 4 is 11, and so on. It's plus 4. And now we have the formula a sub n equal to a sub 1 plus n minus 1 times d. A sub 1 is 3, n minus 1, we don't know that yet, but just for the n minus 1, d is 4. So multiply this out, 3 times 4n minus 4, we have 4n minus 1. So once again, a sub n is equal to 4n minus 1. So a of 20 is 4 times 20 minus 1. That is 79. So that's one way to do it. Another way, if we write this out, 3, 7, 11, 15. To get to the 20th term, we start from 3. Each time we're going to add 4. So we're going to plus 4 19 times, or 19 times 4. Right? Take 19 steps. Take 19 steps to go from the first term to the 20th term. And each step is the minus 4. So 19 times 4 is 76. And that's 79. Right. But this time they do ask for the general term, which is that. Now next one is an interesting problem. The fifth term is 20, the eighth term is 44. What is the 20th term? Well, let's look at the more generic. We stick with the formula a sub n equal to a1 plus n minus 1 times d, right? So let's write that. And so a1 plus n minus 1 times d. Now, for a sub 5 is equal to 20. So we'll put 5 in for n. So a of 5 equal to a1, which is we don't know, and we do know is 5, and common difference we don't know, and that equal to 20. So that gives us what? A1 plus 4d is equal to 20. Now a sub 8 is 44, so put a in for n. That's supposed to be equal to 44. Now a1 plus 7d equal to 44. Right, so we have what we have here is the system of two equations, two variables, so that should be easy to solve for. So of course we can put in the matrix. Remember, we can use the Cramer's rule to solve for a1 and d, or we use matrix equation, a lot of different ways. What I do here instead, just use elimination. Right, so this is a system equation we're trying to solve for. a1 plus 4d is 20. a1 plus 7d is 44. Right, elimination. So we'll keep one, trying to eliminate something, and look like eliminate a1 is a good option here. So I multiply negative 1 on the top. So why do we do that? To do that we have negative a1, negative 4d, and negative 20, and a1 plus 7d equal to 44. Now add side by side, this cancel out. We have 3d equal to 24. So d equal to 24 divided by 3. So d is equal to 8. Now that we know d is 8, we can substitute back in here. a1 plus 4 times d, which is 8, equal to 20. So with that we can get a1 is equal to 20 minus 32, which is minus 12. So we have the first term, we have the common difference. This is easy, right? A sub n equal to a1 plus n minus 1 times d. So now the 20th term is, the first term is negative 12 plus n minus 1. N is 20 minus 1. Common difference is 8. So we have minus 12 plus 19 times 8. Minus 12 plus 19 times 8 is 15. Sorry. I actually hit different key. Okay, make sure. 140. Right, so that's one way to do that. Another way to do that is forget about all the formula. Stick to the fundamental. Just reasoning, right? Think about this. We have the fifth term, so let's try to write out. First term, second term, third, fourth, and this is the fifth term, is 20 for the fifth term. 1, 2, 3, 4, 5, 6, 7, and 8 term is 44. Right, so that's what we have. Now with this, of course, from this term to the next, we're going to need one difference. So 1, 2, and 3. So we need 3 difference to go from 20 to 44. So 20 plus 3 times the difference is equal to 44. Subtract 20 on the other side. That's 24. So D is equal to 24 divided by 3. So D is 8. Now we know 8. If we plus 8, we go to the next term. Do that in reverse. We minus 8. So that gives us 20, 12, 4, minus 8, negative 4, minus 8, minus 12. So we know the first term is negative 12, and then the common difference is 8. The rest is easy. We can write the 20th term. Right. So that is the formula for the n term in general. Is start from the first term and we take n minus 1 step to get to the n term. Next we have the sum of the first n terms on the arithmetic sequence with the first term a1 and the common difference d is d. So the sum of the first n term of arithmetic sequence is this. Right. So this is actually not a proof. It's kind of a story, a motivation of how did the formula come about. So let's think about this and look at the problem. Very simple one. If we add 1, 2, 3 all the way to 100. This was not a proof, by the way, kind of a classical problem. What's that equal to? For that, let's S be the sum, right? What's that equal to? Now, of course, we can add everything by hand, but this solution, the classic solution, is genius. So instead of writing from 1 to 100, let's write it in the reverse order. 100, 99, 98. Of course, reverse order, we have 3, 2, and 1. And when we write like that and we add side by side, on this side we have 2s. And we have 100 plus 100 plus 100. And that, sorry, 1 plus 101. And if we add by column, we have 101. We just keep adding all of them. And since we have from 1 to 100, we have 100 of this 101. So we have 2 times s is equal to 100 times 101. I'm not going to multiply it out. I'm just going to keep it like that. And then divide by 2 on both sides. So the sum is equal to 1/2 times 100 times 101. Right? Now, as that related, which is 50-50, by the way. It's not really a proof, it's just a classic problem. Now, how is that related to the formula we have here? Now, if I rewrite this as, we can have 100 divided by 2, and then 101, we can say 1 plus 100. So pretty much is equal to how many terms we're going to divide by 2, and then the first term plus the last. So n is the number of terms divided by 2, the first term plus the last. Not really the last term because the sequence is indefinitely, but the last term is the n term, I should say. And since a sub n is equal to a sub 1 plus n minus 1 d, substitute, and that's what we have. So if we substitute a1 plus n minus 1 times d for a sub n, so we have a1 plus a1 make that 2, and then n minus 1 d, right? So number of terms divided by 2, the first term plus the n term. Right. We have a couple of examples here. Find the sum of the first 100 terms. The sum of the first 100 terms is s of 100 in a arithmetic sequence, right? So in this case, we have 1 is the first term. To get from the first to the second, we're going to plus 2 every time. So common difference is 2. That's what we have. So in the formula, either we're going to have n just try in general first. a1 plus a sub n. So in this particular, we're going to have 100 equal to 100 divided by 2 a sub 1 plus a sub 100. The only problem is we don't know a of 100, which is fine. We can just go ahead and find it. Now for the 100 term, the first term is 1. To go from the first to the 100 term, we have 99 times. Common difference is 2. So that's 98 plus 1. I'm sorry, 198 plus 1 is 199. So we have 100 divided by 2. The first term is 1. The 8 of 100 is 199. So that gives us 50 times 200 is 10,000. Right. One way we can check is using the summation. We will add from the first term to the 100 term, and each one is going to be, the first term is 1 plus n minus 1 times 2. So we're going to add 100 terms of those, and that's what we have, right? So the sum of the first n term is number of terms divided by 2, the first term plus the n term. If we don't know the n term, find it, and that's what we have. Next, we find the sum of this to 75. In this case, we don't know how many terms we have, but we certainly can find it. One thing for sure, the first term is 5, and from this term to the next, the common difference is also 5, plus 5, plus 5, and so on. Right, so s of n equal to n over 2 a1 plus a sub n. So this time we know a1 is 5, a sub n is 75. We just don't know n, right? So we certainly can find it. Again, same formula. we don't know what is the term, but that is going to be equal to 75. A1 is 5. N, we don't know n. Common difference, we know that is 5. Alright, 75. 5 multiply them out, 5n minus 5. 5n minus 5 cancel out. 5n is 15. 5n is 75. So n is 75 divided by 5, which is 15. Right, so we know it's 15, so we can put that in here for n. So we have the sum of the first 15 terms is 15 divided by 2, the first term, and the n term, which is the 15th term, 75. Right, and that 15 over 2, 575 is 80. 80 divided by 2 is 40. 40 times 15 is 600. Alright, so let's see if it works. We want to sum the first 15 terms, and each term is going to be A1 5 plus n minus 1 times 5. Yeah. So in this section, the n term is given by this. The first term plus n minus 1 step to get to the n term, n minus 1 times d. And the sum of the first n terms is the number of terms divided by 2. The first term plus the n term. We don't really need to use that, because that's just the summarize of when we substitute that into a sub n. And that's all I want to cover in this section. Thank you for watching. See you in another video in course algebra.